at 13.3. These first few slides, it's just some multiple choice on knowing the sides to a special right triangle. Okay, we got our 30, 60, 90, and 45, 45, 90. Now, if we look at a 45, 45, 90, it's a root 2. Now, for our sake, we're just going to consider a as 1. So their sides are 1, 1, root 2. Okay, for 30, 60, 90, it's a, 2a, root 3. So the one that's opposite of 30 degrees, again, we're going to consider a to be 1. So 2 times 1, or 2, and then square root 3. So 1, 2, square root 3, that's what we need to remember for 30, 60, 90, and 1, 1, root 2 for 45, 45, 90. That's going to help us with evaluating trig functions of any angles. Now we got a little acronym here. All students take calculus. It's what's going to help us determine the sign when we evaluate trig functions at any angle. Okay, all students take calculus. Okay, quadrant 1, 2, 3, 4. A is standing for all trig functions. S stands for sine. T is tangent. C is cosine. Okay, now what that is telling us is what trig functions are positive in which quadrant. Okay, so in quadrant 1, all trig functions are positive. Okay, no matter, saying like you're evaluating cosine of 45 degrees. 45 degrees lands in quadrant 1. So no matter what trig function you evaluate at that 45 degrees, it's going to be positive. Moving to quadrant 2, so anything between 90 and 180, if you are evaluating sine or cosecant, which is its reciprocal, if you're doing sine or cosecant of an angle that's between 90 and 180, that will be positive. If you move to the third quadrant, if you evaluate something between 180 and 270 and it's tangent or cotangent, that's positive. And then finally in the last quadrant, quadrant 4, if you evaluate something from 270 to 360 and it's cosine or secant, that should be positive as well. That will help us later when we evaluate trig functions. Now, we are going to evaluate if we were to do a terminal side through a specific point. Now, what's going to help us is, I'm just going to do the drawing. Okay, let's say we had a point x, y. Okay, and we're doing a terminal side that goes through that point of x, y. With that, there's a few things I can determine. I can create a right triangle by dropping what's called an altitude towards the x-axis. Okay, I know this distance is x because we went right x and we went up y, and then we're going to consider the hypotenuse r. Okay, a big thing comes to creating a right triangle, and we got our angle there. And so if we look, okay, sine of theta is equal to y over r, or sine is opposite over hypotenuse, so y over r. Okay, if we were to do this cosine based off that picture, x over r, tangent y over x. Okay, and then it's reciprocals. So these right here, if you know those or you know how to get them, okay, that's going to help you, especially when we start doing quadrantal angles. Okay, so let's start off with an example. Let's say we got the point -4, -3. Okay, there's that point, and we're going to have draw a terminal side through that point. Okay, let -4, 3, -3 be a point on the terminal side. So that's arrow there is our terminal side of theta. Evaluate the 6 trigonometric functions of theta. Okay, so you're going to draw that terminal side, and then you're going to, well, no matter where you are, okay, let's say your point is here, you're going to drop an altitude to the x. Let's say you're in quadrant 4, you're going to go up to the x-axis. You're always going towards the x-axis to make this right triangle. Big mistake is to go to the y-axis. Do not do that. Okay, it always goes to the x-axis. Now, given that triangle we just created, we know that this is -4, and we know that this is -3. And since it's a right triangle, we can use the Pythagorean theorem. A squared plus b squared equals c squared, or -3 squared plus -4 squared equals c squared, or 9 plus 16 equals c squared, or 25 equals c squared. So that radius, or that c value, is 5. That one will always be positive. Now, so we're evaluating from this angle. The angle is always the one near the origin. So sine opposite over hypotenuse, which will get -3/5. Cosine of theta adjacent over hypotenuse, so -4/5. And then tangent opposite over adjacent, so -3 over -4, or +3/4. Now, cosecant, that is the reciprocal of sine, so just flip-flopping it, -5/3, -5/4, and then finally 4/3. Okay, that's evaluating given a point, and that's the terminal side. Okay, we'll skip that one, but that is how you do it given a point, evaluating your 6 trig functions. I will do this though. Actually, I will put what they would be if you were to practice those problems. Okay, you would get -5 over square root 29, but then rationalizing it, you get -5 root 29 over 29, 2 root 29 over 29, -5 halves, negative square root 29 over 5, square root 29 over 2, and then -2/5. Now, one thing I do want you to notice, if we did a quick sketch, 2, -5, that's putting us in the 4th quadrant. All students take calculus, okay? So cosine and secant should be positive in this case, which they were. Okay, quadrantal angles. Now, if the terminal side of an angle in standard form lies on the axis, then the angle is a quadrantal angle. So whenever they land on the positive x-axis, 0, 90, 180, 270, 360, or in terms of radians, 0, pi over 2, pi, 3 pi over 2. Okay, those are all quadrantal angles. Now, to evaluate those quadrantal angles, knowing that y over r and x over r is going to help. So we're not going to do that one. So like in this case, if we had a coordinate plane, that's our angle, and we want to evaluate that, we're going to take any point on that terminal side, and we're going to say 0, 1. We can do 0, 2 if we want. Now we have x, now we have y, and then we also have that radius. Since y, the distance from the origin is just 1, so we have x, y, and r. So if we go back and we look at our y over r, x over r, all that, that's going to help us evaluate our trig functions on a quadrantal angle. Okay, you're just going to pick that point, figure out x, y, and r. So if we evaluated this, because we got x is equal to 0, y is equal to 1, r is equal to 1. So sine of theta, or in this case sine of 90, equals, we'll say y over r. Okay, so y over r is 1 over 1, or just 1. Okay, cosine of 90, which is x over r would be 0 over 1, or just 0. Tangent of 90, we're going to get y over x, so 1 over 0, which is undefined, because we cannot divide by 0. Okay, and then cosecant of 90, r over y, which would be 1 over 1, or just 1. Secant of 90, r over x, which would be 1 over 0. Again, that one is undefined. And then finally, cotangent of 90 would give us x over y, which would be 0 over 1, which we can do. It's just 0. Okay. So evaluating quadrantal angles are a little tough. You got to think about it in terms of that x, y, and r. It makes it a little bit easier. Okay. Now, reference angles. The reference angle of theta is the acute angle. Okay, and you notice it's like theta with theta prime, you can say. That's got that little dash formed by the terminal side of theta and the x-axis. The big thing there, the x-axis. So if we got an angle of 140, what we're going to do is we're going to draw that angle. Okay, for 140, I know that's in quadrant 2. Okay, if we go straight on the positive y-axis, that's 90. So we've got 90 degrees. We got to go another 50 degrees. Okay. So it's a little past halfway. Now, so I know this right here is 150 degrees. This part right here. Now what I want, the reference angle is always going to be the angle created with the x-axis. Again, the x-axis right here. So this is the angle it's creating. That is my reference angle. So we know that a straight line is 180, so another 30 degrees gets us to that. So our reference angle in this case is 30 degrees. Now, if we look at it in terms of radians, okay, if you remember, a straight line is pi, okay, and we're splitting that pi into 4 pieces. So I'm going to split it up. 1, 2, 3, 4. I'm going to split all the quadrants in half. Okay, so I got 1 pi out of 4. So if you remember, each piece is 1 out of 4, and I want 3 of them. So 1, 2, 3 pieces. That's my angle. Okay, and if you also think of pi as 180 degrees and you split it up into 4, each chunk there is like 45 degrees. So it's like we have 135 degrees so far, so I need to go another 45 degrees here. And again, the acute angle is smaller than 90 degrees, so in this case my reference angle is that acute angle, the purple, and it's pi over 4. We got to go one more piece of that pi to get to that x-axis. Okay, these reference angles are very important when we evaluate trig functions. Okay, because we're going to find that reference angle after we've sketched our angle, evaluate using that reference angle, and then determine the sign using all students take calculus again. Okay, so I'll do a couple examples. So cosine of negative 150, first thing we need to do is we need to sketch that angle. Now remember, negative 150 means we're going clockwise, so negative 90 plus another 60, meaning right here would be a 30-degree angle. Because if I went negative 150, and again, when you start using reference angles, it's always use the positive. So if you've noticed, we created a 30-degree, and we're going to create a right triangle by drawing that altitude up to the x-axis. Again, do not do the y-axis. Do not do that. It always goes to the x-axis. Now, if you remember, now we got a 30, 60, 90, because that will always be a 90-degree angle there. And we should know our sides to a 30, 60, 90 triangle. Okay, if you don't remember, 30, 60, 90, opposite of 30 is 1. Okay, hypotenuse is always 2, and this will be square root of 3. Okay, and the function that we are evaluating now is cosine, and we're evaluating it from that angle, always the one that's next to the origin. So cosine adjacent over hypotenuse, which will give us square root of 3 over 2. Okay, and then if we remember, all students take calculus. T is the quadrant 3, so that tells us just tangent is positive, meaning cosine should be negative. So the cosine of negative 150 degrees is negative square root of 3 over 2. Now another way you can think about this, we went left, so you can think that's negative as well. And we went down, so that's negative. So remember, anytime you go left and down, that's negative. If you go up or right, that's positive. If you do it that way, you get negative square root of 3 over 2 right away, which will help you with your sign. Otherwise, you can use the all students take calculus, which is a good way to check your answer in the end as well. We'll skip that one. Let's do sine of 225. Now, okay, let's initially draw our angle. Positive, so we're going counterclockwise. 90, 80, 90, 180, and I need to go another 45 degrees. Okay. So we'll create a right triangle. So this is my reference angle right here, which is going to be 45. Okay. This will also be, so since that's 45, we created 90. It's a 45, 45, 90. So we got 1, 1, square root of 2. Since we went left, it's negative. We went down, it's negative also. And if we're evaluating sine, that's opposite over hypotenuse. So opposite over hypotenuse, we get negative 1 over the square root of 2, which we rationalize, we get negative square root of 2 over 2. Because again, just multiply by top and bottom by square root of 2. And there we have our answer for sine of 225. Now just doing a quick double check. All students take calculus. Again, tangent should be positive in quadrant 3. We didn't evaluate tangent, so our answer should be negative. All right, now let's do it in terms of radians. Negative 2 pi over 3. So we're splitting up the straight line into thirds, which is going to be a 60-degree angle. 180 divided by 3 is 60. So we want to go 2 pi out of 3. So this is our angle that we got. And we're going to use our reference angle here, which would be 60 degrees. Okay, because again, pi over 3 is the same thing as 60 degrees. Okay, so we've created our reference angle, and if we do our altitude, we have created a right triangle. Since it's 60 degrees there, we got a 30, 60, 90. Opposite of 30 is 1. Hypotenuse is 2. Square root of 3. Again, we went left, so negative, and went down, negative. And what we're evaluating is secant, which you need to remember is the reciprocal of cosine. So adjacent over hypotenuse, we need to do hypotenuse over adjacent. So 2 over negative 1. Oh, let's go here. Let's get rid of this, which would be just negative 2. Students take calculus. So meaning tangent and cotangent are positive. We didn't have that, so we should have a negative answer when we evaluate that trig function. Okay, we will do some more practice with this in 13.3 day 2. Nothing new in that video, just more examples of this. Other than that, start working on your worksheet. If you have questions, make sure you're coming in during office hours. Have